All right, we'll go ahead and get started. Thanks for joining us with our Raising Your Dairy Best Heifer webinar series. This is our second season of our Heifer webinar series. So welcome you here today. My name is Jennifer Bentley, and I work as a dairy field specialist with ISU Extension and Outreach, housed in Northeast Iowa. And we're excited to have another topic here on our Wednesday webinar series here today. But as we get started, just wanted to kind of give you some webinar guidelines as you're getting situated here, just making sure that people are muting their mics to reduce any background noise and distractions from the webinar. If you have any questions, go ahead and put those in the chat box for comments, or if you have any technical support, I can kind of navigate that through the chat there. And then also this is going to be recorded, so we'll share this out to our participants. We had our first webinar last week talking about pair housing, so that is out on our YouTube channel and available for people to go back and review. And so give us about a week to get this edited, and then we'll have it posted out on our YouTube channel as well. So today we're going to be talking about positive biofilms in calf health, and excited to have Dr. Sarah Morrison, a research scientist with Minor Institute, with us here today. I do want to remind you of our upcoming webinars. So these are going to be mostly on Wednesdays coming up through October up until the first week of December. So you'll see there next week, we're going to have utilizing genetics to improve dairy calf health and performance. That's going to be with Dr. Isaac Hagan from University of Minnesota. So looking forward to that presentation as well. So with that, Dr. Sarah Morrison, I'm going to go ahead and stop sharing my screen, and you can go ahead and share yours, and I'll do a little intro for you here. And just letting people know that Dr. Sarah Morrison is a research scientist at the William H. Minor Ag Research Institute in Chazy, New York. She grew up on her family's dairy farm in Addison County, Vermont, and earned a bachelor's degree in animal science from from University of Vermont. She went on to complete both her master's and PhD in animal science at the University of Illinois, where her graduate research focused on dairy calf nutrition and health. And she has joined the Minor Institute in 2018, and since then has led a research program focused around dairy calf health, heifer and cow nutrition and management. And her work wants to improve animal health, productivity, and overall farm efficiency. So with that, Sarah, I'll give you the floor here to talk about positive biofilms in calf health.
Well, thank you very much, Jennifer, for that introduction and for having me today. Just a little bit more about Minor Institute for those who might not be as familiar. She said, we're in Chazy, New York, which is very much northern New York. We're close to the border, probably about 40 minutes from Montreal. So, um, kind of the northeast corner of the state. Um, we're a not-for-profit research organization, so our three pillars are really research, education, and outreach. So we have a 580 lactating Holstein herd. And so some of the buildings are shown here. We've actually expanded since this picture was taken, so I needed to update this. But we have the facilities to support the lactating herd. We're highly productive with an average over 105 pounds a day, or um, or one for 2% fat and 2% protein. We have new facilities for our calf and transition heifer with plans to kind of phase out the rest of our heifer programs. And then the other part of the dairy complex, and we also have an equine program, is the education as well. So we have programs throughout the year that support those, and then we do a lot of public engagement through different outreach there. So today, I'm going to be talking about positive biofilms in calf health and really thinking about strategies that producers can implement to improve calf growth and intestinal use. Biofilms probably historically have been a bad word and something that you look to avoid, but I'm going to give some examples where we can actually use these to our advantage. And it kind of ties into some of the probiotics or other direct fed microbials that you might have heard about in our calf nutrition or even dairy cow nutrition programs. So if I can get things to go. So just starting first in an overall kind of perspective, if you're working with calves and heifers, right, one of the biggest challenges that we often experience is diarrhea or other digestive programs kind of paired with the respiratory infections that you might be. Those are kind of the two big ones that we're often combating with our calves. It, it really leads to a lot of morbidity or treatments of these animals and mortality causes from some different surveys that have been done across the United States. And we know that this doesn't only impact the calves at the time when they're sick, but the number of days that they're sick and the treatment with antibiotics in that pre-weaning period has been linked to decreased lactation performance. So it not only affects her productivity at the time of that illness, but also can impact her overall productivity within the herd. So thinking from a big picture, what can we do to kind of minimize those influences at this stage so that we're getting the most productive animal when she enters lactation? And so when I was at Illinois and doing my grad program, we had run several different studies within the lab, and I got interested in this area and trying to understand more about the impacts that diarrhea and these digestive insults really have on calves. So we had a data set of 4 experiments that we had conducted under similar conditions, and that totaled over 300 calves. And so we really paired them off. So we had done fecal scores of the animals when they were on the studies. And this is our typical kind of scale where 1 and 2 would be normal. So we classified those animals as healthy. We had over 200 calves characterized that way. And then any animal that had a score of 3 or 4, which you start to get very liquidy diarrhea, for 3 days or more, we classified those as diuretic. And we had 96 calves in that. And so we were focusing on the first, these were calves that we brought in from an outside farm or source. And we really focused in on the first 3 weeks after they arrived to the facility. And so when we looked at the incidence and duration, just out of how we describe them, you would expect that the calves that were classified as diuretic, they had a higher likelihood. So this is kind of an odds ratio where we compare to the healthy calves. One would be there would be no difference to the control, but you can see that the calves that were classified as diuretic, they had almost a 6 times more likely to have diarrhea during that period. They're also almost 3 times more likely to refuse milk replacer during that time. And obviously, as part of our management of diarrhea, one of the things is electrolyte therapy, making sure we have supportive fluids for these animals. So they were much more likely to receive electrolytes based off those fecal scores that we were observing. And then overall, the incidence of like number of days between these different groups, we had almost 2 days of diarrhea for even the calves that we classified as healthy. So still some observations that way in terms of looser stools, but then close to 7 days for those calves that were classified as diuretic. And again, more days where they were refusing milk replacer and more days where they were giving electrolytes. So from these studies, we were actually looking at a bunch of different data, right? We were collecting initial total protein, which interestingly, we didn't see much of a difference between these two classifications, and they were still considered fairly good. The average temperature during this time, calves were a little bit more likely to have diarrhea when it was warmer temperatures out. And then we looked at some cumulative intake of milk replacer, starter, total dry matter intake, and water, as well as electrolytes. And you can see that when calves were diuretic, they were consuming less milk replacer, they were refusing it. They were consuming less starter, and this is a big one that I'm going to hit on in a second. And then overall total dry matter intake was lower. We also were measuring free water intake, or what we just offer in a pail to the calves. And so you can see from the water that they were consuming from milk replacer or that free water, they were actually consuming or kind of self-regulating a little bit with how much water they were consuming. So I think that is another thing that we need to kind of keep track of. This wasn't significant technically, but they will still consume water when they're experiencing diarrhea. So I think having that access as well as administering electrolytes was a big take home for me. Then when you look at the performance between these different groups, initial body weight was similar, but then at the end of the 21 days, the calves that were diuretic, they had less body weight, and I'm sorry, this some of this is in kilograms, but about 4 pounds difference between these animals. So they were eating less milk replacer, but they were also had that demand of that illness, so had kind of less available to grow. And their average daily gain was lower as well as their final body weight. And so with this combination, we see some reductions in feed intake, but also growth. These calves had lower efficiency when you look either on a milk replacer basis, which is primarily what they were consuming during this time, or their total dry matter intake. So they're less efficient because they're also combating this like illness or the disease that they were faced with. So obviously these animals are more challenged than calves that remain healthy during this time. And so I mentioned the difference with the starter intake, and this was a big take home for me. These calves are all fairly young, less than 7 days of age when they came to the research facility. And you can see in the 21 days after arrival, you have starter dry matter intake. The calves that remained healthy, even though we don't expect an appreciable amount of starter intake during this time, that they were starting to eat more starter, especially when you compared it to the calves that had diarrhea. So when we're looking kind of holistically at our calf management programs, we want to promote this as much as possible during this early pre-weaning period so that we can get them towards weaning. And so this really had an insult to that potential starter intake. So anything that we can do to minimize this is going to be positive in terms of increasing the productivity of these animals, right? We know that diarrhea results in reduced feed intake, lower body gain, body weight gain, and efficiency. So we know that there's a lot of diarrhea and other digestive issues that kind of assault a calf within that early pre-weaning period, especially within the first 3 to 4 weeks. There's different stressors that can really influence the calf's likelihood of getting sick within this time. Even some things like dietary changes, changes in how much solids they're fed day to day, the consistency of that when we get later in the pre-weaning period and start to wean them. That's also a challenge for the gastrointestinal tract, where it's a very big change if you think about going from essentially a monogastric non-ruminant to a functioning ruminant within several short weeks. Furthermore, you might see certain times of the year calves are challenged more than others, right? If we get into cold stress and we're not addressing the changing requirements for those calves, they'll have less available for growth. Or when we get into heat stress, that also can cause challenges for these calves. If you think about the different environmental pathogens, right? Bedding, housing, hygiene, how are these conditions impacting or kind of influencing what that calf is exposed to? And then all of these can kind of lead to diarrhea, and other insults like that. Sometimes antimicrobials are used. We've often tried to limit this, and often they're not even effective for what's actually causing the insult or the diarrhea within the calf. So when I think about the gastrointestinal tract, we're really thinking about this kind of ecosystem where microbial populations are actually critical for the energetic status of cattle across the life cycle of an animal, right? We have these great symbiotic relationships within ruminants where she has a population of microbial um, bacteria, fungi, protozoa that are actually helping to degrade a variety of feedstuffs. This helps promote growth, production, and feed efficiency. And it's a really important kind of aspect of why ruminants are so awesome. But then also they come into play in terms of microbial populations and food safety, right? Or animal health. Are they getting exposed to different things that could put these two factors at risk? And then again, the environmental impacts. So this is kind of like the big three that I keep in mind when I'm thinking about the gastrointestinal tract and how these things really play together quite closely. And when you have the mucosa, which is more of the host or the animal side of things, specifically thinking the mucosa, the gastrointestinal tract, the small intestine. There's different things that might influence a cow's specific susceptibility to different things. We have the feed that we're giving to the animal to use, or maybe the microbial population. So what nutrients are there? What feed additives can we put in there? Or maybe what contaminants are in that feed that might be more of a challenge to that animal. And then the final kind of leg of this is the microbial populations, right? We have a lot of commensal bacteria, which are normally associated with different systems within the animal. Those are all good things that we want to have there. But then again, there's always the potential to have different pathogens or bacteria or other things that could get out of hand. But when these function all together, this really optimizes the health, the utilization of the nutrients that that calf is consuming, and it works really well together. So what can we do as a way to kind of really promote this and optimize these interactions across that animal? So when you think about the gastrointestinal tract of a ruminant animal, a calf in specifically, it really evolves over the pre-weaning period. So I mentioned that they really start out more like a non-ruminant, right? They function more like a monogastric, where the nutrient utilization and absorption is primarily within the small intestine. And so in the small intestine, this is a single layer of cells that really prevent what's outside of that calf to the inside and what she's absorbing. So this is really important for our calves. It's really important when we're feeding milk or milk replacer. This is where those nutrients are going to be absorbed. But then in fairly short order, right, we're developing this rumen, which looks very different structurally. There's more cells between the contents of the rumen and the animal. So there's kind of a little bit more challenge in terms of the susceptibility of gastrointestinal insults when they're younger and more focused on the small intestinal aspect of the that time period. And so if you think about the function of intestinal epithelial cells, it's really providing first and foremost that selective absorption, right? We want to have these animals absorb the dietary nutrients that we're giving to them, the different fat, protein, energy sources. Um, but this is really a barrier to prevent translocation of what else is in there, as including the different foreign antigens, things that we might not want to get across that barrier. So whatever microorganisms are in the lumen of the intestine, or maybe toxins that the animal has consumed. So again, there's different cells that make up the lining of the small intestine, and so this is where all the feed that calf has been consuming. There's different commensal or positive bacteria that are normally associated with this and help to maintain this barrier. And so we want them to be there, but we don't want to kind of get that imbalance where we might have crypto or rotavirus or other things that could also be within this lumen across that barrier. And so this really depicts that kind of balance between what healthy microbial systems and a depleted microbial system might look like. So on the right-hand side, you kind of get a snapshot of the small intestine, where the purple are commensal bacteria that are normally associated with this mucin that helps kind of form that barrier. We've got our cells. They're kind of normally detecting what else is there. So these really help to create niche competitions. They help to compete for colonization, nutrient absorption. They help to limit the pathogen expansion by helping to stimulate some mucin and other immune functions within the gastrointestinal tract, kind of locally here. And they also help to stimulate these other immune responses so that a calf can appropriately respond to something that is there when necessary. However, if we get a depletion of these normal microbial populations, that's where we can kind of tip the scales and get more of those diarrhea events or other things that we would visually see the calf is negatively affected because something is causing this to um, reduce, and there's more opportunity for these pathogens to really challenge that animal. And so there's a host of different things, right? You probably have come across different viruses, bacteria, or protozoa that can lead to this. If we get an imbalance, that's where we'll see if we're testing the manure, rotavirus, coronavirus, and others kind of taking over and really dominating this interaction here. So the impacts of altered gut function, if we think about those insults, there's going to be more permeability. They're going to be more susceptible to damage within the gastrointestinal tract. So we really need to determine methods to minimize the severity and economic impact that diarrhea and this disturbed intestinal integrity has on calves. There's certainly a risk of issues. We've noted reduced feed intake and efficiency, and there's obviously some lasting impacts in terms of how many days they might be sick or if they've been treated with an antibiotic. And I also like to think about, are we doing stuff in terms of prevention versus recovery? Obviously, if a calf is sick, we need to kind of recover her in the fastest way possible to promote that healthy microbial composition across the gastrointestinal tract. But ideally, we'd like to prevent this and kind of tip the scales in our favor and minimize the overall severity to begin with, right? And so just to kind of capture this again and put it into perspective. So we're really thinking about different ways that we can kind of tip the scales in our favor and promote a strong host to microbial interaction where we have good commensal bacteria that help support a strong barrier function and absorption of nutrients so that we can really optimize this interaction between feed, microbial communities, and the animal as a way to kind of promote the success of these calves as future replacements within the herd. So thinking about beneficial bacteria and gut microflora, what early interventions are out there for gastrointestinal tract benefit? Are there things that can help establish, stabilize, or diversify the gastrointestinal tract bacterial populations and really help to promote a synergy between the beneficial bacteria and that intestinal epithelium? It's kind of the big goals of what we would look for in terms of identifying bacteria or other factors that might help promote these systems. So one thing that might come about if you're talking about different programs, there's a lot of direct fed microbials or DFMs, and there's different categories. So these terms you may find are used kind of interchangeably, but I think it's helpful to kind of know the different categories and how what they might be called and different types that kind of fall into this. So under this kind of large umbrella of direct fed microbials, the first category is eubiotics. So this is kind of the maybe interchangeable with direct fed microbials. It's pretty all-encompassing and includes feed additives that play an essential role in supporting animal performance, welfare, and health. And so any product type, including organic acids, essential oils, probiotics, prebiotics, postbiotics, and phytobiotics, which some of those are described below, kind of fall into this category. So pretty vague and probably would be interchangeable between these two things. Where we get a little bit more specific is when we start talking about probiotics, which are actually living microorganisms, which, when administered in the adequate quantities, are beneficial to the health of the host. And so these include live bacteria, yeast, or fungal cultures. You may even use this within your own or take a probiotic yourself. There's a lot of benefits that way. And if you kind of look on different packages or pay attention to some different feed additives, you've probably come across some probiotics within the calf or cow nutrition already. The next one would be prebiotics. So these are from fermentable substrate not used by the host animal. It's really meant to be used by the actual commensal bacteria or um, microbial communities that might kind of use that to feed themselves and promote their growth. And so these could include oligosaccharides or inulin. Then a postbiotic includes yeast or fungal products or their product of fermentation. So you might see like yeast cultures or cell wall components that are fed as a way to kind of signal different things within the gastrointestinal tract um, and promote different benefits that way. And then you might have one that includes a symbiotic um, relationship. So feed additives that work synergistically through multiple modes of action. So this might be you're feeding a probiotic, but also a prebiotic at the same time. So you kind of get multiple benefits of what these could provide. So these can function in a host of different ways, and it kind of just depends on what you're actually feeding. So these different direct microbials could help shift the microbial environment via acid production. Like an example would be it might lower the pH from lactate production. They might promote more lactate, so the pH would be lower. They also might shift the molar proportion of short chain fatty acids. Maybe they help to promote butyrate, which is a great VFA for rumen or small intestinal health, or they might influence the gut permeability and increase the gut integrity by changing these different short chain fatty acids. They could help increase that competition for nutrients, substrates, or cofactors, kind of creating a competitive advantage to certain populations within the gastrointestinal tract and kind of outcompete the negative ones that are there. They could also compete by actually physically binding to different sites within the gastrointestinal tract or supporting some of that mucin production. And then some of them may have some antimicrobial compounds that could kind of compete that way, kind of negatively impact other microbial populations within the gastrointestinal tract. There could be some inflammation or immunostimulation through the administration of that, or they could kind of stimulate growth hormone or other inflammatory pathways, or any and all combinations of these, depending on what the product is. So it just depends on what that specific product might actually do for the animal and how it's administered. So I started out by talking, we were going to talk about biofilms, and probably historically, biofilms have meant negative connotations, like in the milk pipeline or challenges with mastitis, buildup of things that are bad. So what a biofilm is it's actually a cluster of live bacteria attached to a surface by an extracellular matrix or EPS. It's formed as a survival and proliferation mechanism to protect bacteria from harsh environmental conditions. But nearly 90% of all bacteria exists within a biofilm. So they can't all be bad, right? This is kind of a schematic that really shows that biofilm formation. So it starts with reversible attachment. There might be some free bacteria that are within the environment. They adhere to a surface there, and then they start to secrete this exopolysaccharide that helps to protect them. They start to reduce their motility and don't move around as much. And then through this process, you kind of have different cell sensing, and there might be other things associated with this. You can see changes in gene regulation and expression. And then as that matures, the cells live and reproduce. There's some quorum sensing, and there's different nutrient channels. So it's like kind of a whole network within this system that they're really kind of talking to each other and existing there. And then when you can get detachment of cells, that's where we sometimes have gotten into problems, but that's where they kind of release those cells from the biofilm into the environment and they can kind of proliferate and attach somewhere else. So the exopolysaccharide is really the like the part of this biofilm that's really of interest. And so this is a secondary metabolite produced by bacteria. If you've looked at one before, it's kind of slimy, and that kind of indicates the biofilm presence. So in our milking equipment and stuff, this would be negative, and we wouldn't want to have this, but it's an obvious kind of this is a biofilm forming here. But the interesting part of this is that there's actually a lot of bioactives that are of interest within this exopolysaccharide matrix. There's opportunities as edible food coverings and natural preservatives, different drug delivery vehicles, gut and immune health modulators, and it could have antimicrobial alternative potentials. And so these could work alone or in concert with the bacteria and other metabolites that they might be housing. And so while we historically probably thought about biofilms in a negative connotation, there is some opportunity to use these for good in terms of different livestock systems. And so if you think about the category of probiotics, again, these are the living strains of bacteria, yeast that we often feed to animals. So when we administer them in the adequate amounts, either through milk or starter, if you're thinking about calf nutrition, they can confer a health benefit. There's been work that has shown earlier feed consumption and also improvements in growth. And so these are kind of some examples. If you're looking at bacterial-based ones, we might see some lactobacillus, some bifidobacterium, some bacillus species, and enterococcus, what might be examples of ones that you could have come across. And then from a yeast-based one, so if we have live yeast, you might have used Saccharomyces cerevisiae before, which is from dried fermenting living yeast. And so these are some of the rates that we might feed it, or even yeast cultures that are products of this yeast fermentation. So we might feed the media that the yeast were actually grown in and the cell wall components that might confer some of these benefits as well. So when we're thinking about calf health, nutrition, promoting growth, one of the things that we got interested in at Minor was actually kefir as a probiotic source. So kefir is basically a drinkable yogurt, and I kind of use the analogies. It's somewhat like keeping a sourdough starter or like yogurt fermentation. So kefir is actually sold in the supermarket. If you're looking in the dairy aisle, you might have seen like a mango or strawberry kefir. That would be my preference for consuming this. But it's kind of like that drinkable yogurt consistency. But this is what it looks like when it's being fermented. And so it is that fermented milk beverage. You would take some milk, and it has a lot of probiotic properties. It's very much rich in beneficial bacteria, yeast, and fungi. It has over 60% lactobacillus. Like I said, the viscosity and texture provided, like that kind of drinkable yogurt um, um, texture, is from that exopolysaccharide uh, kefir, which makes this fermentation. And so this exopolysaccharide within the kefir has a lot of potential benefits. And when we were thinking about things that we could implement on farm, this is a really cost-effective and easy on-farm probiotic supplement that you wouldn't necessarily have to purchase yourself, but you could actually make yourself and do it on your own. So this is kind of the process of using these exopolysaccharides, or this is essentially the biofilm that the kefir grains, which they're called, you would add to the milk and make this fermentation shown here. So this is as the milk is being fermented. Then you can strain off these kefir grains and kind of perpetuate that into the next fermentation. So once you have your kind of initial starter, you can kind of keep making more of the kefir as long as you keep feeding it, kind of like that sourdough or other things that people are into. So when we were thinking about this as a way to kind of mitigate some of the antimicrobial use or health benefits, we've done some work with the Cornell Extension Group where antimicrobials are not always necessary or effective, especially in gastrointestinal tract illness. And so we did a study where we were analyzing the feces of calves with diarrhea, and only 23 of the 72 calves had an actual bacteria infection identified. The rest were protozoa or viral infections. So it kind of indicated that antimicrobials were not necessarily necessary in that case or would have been effective. And so the thought is really that if we are feeding probiotics and kind of tipping the scales to benefit the calf gastrointestinal tract, we could promote this gut health, maybe improve growth and intestinal integrity of these pre-weaned calves. And so kefir definitely kind of fit that bill as something that we could look into and kind of evaluate if it would be effective on different farms and calf health. So we had a couple different studies. The first one, we looked at the effect of kefir in the liquid diet for the first 21 days of age on growth, diarrhea incidence, and antibiotic use. And the reason that we just focused on that 21 days was, again, that kind of like heightened susceptibility during the first 3 or 4 weeks. We figured that if we were going to see a benefit, we were thinking it was going to be from the gastrointestinal tract health of these calves. Maybe they'd have lower diarrhea incidence. And so we're just going to focus on those first 3 weeks and not worry about the whole pre-weaning period. So for this study, we had a control and a treatment where we were feeding kefir. And we actually had 3 different farms that we evaluated this on. So the first farm was minor, and so we did a little bit more of a controlled study there. But then we had 2 partner farms where we actually asked farms to make the kefir themselves, administer it to their calves, and evaluate under different management conditions. So the first farm, we had 62 calves. They were housed individually in a mechanically ventilated barn. We fed a milk replacer, kind of a step up, step down according to their normal program, and a starter. Then on the partner farms, we had a few less animals, but they were the farm B was housed outdoors in individual hutches bedded with sand. They were fed whole milk and a commercial calf starter. And then farm C, they also housed their animals in hutches with sawdust. They fed pasteurized whole milk and they had their own grain mix as well. So we're thinking that we're going to see some great benefits in terms of health of these animals for the calves fed kefir. So you can see the control versus the kefir, and this is an odds ratio. So we're comparing the likelihood of kefir calves having an elevated fecal score compared to the control. So one again is kind of no difference. So you can see that there wasn't a difference in fecal score, respiratory score, dehydration score, or time to first event of diarrhea or the need for treatment. So we really didn't see a benefit of feeding kefir during this 21 days or thereafter in the pre-weaning period from feeding kefir. Some interesting things that we did find was that there were some slight improvements in growth and average daily gain. We kind of looked on each farm individually. On farm A, we didn't see a difference in body weight, average daily gain, or feed efficiency. We did see a little bit increase in heart girth. On farm B, we actually did see a benefit of feeding kefir. So those calves that were fed kefir had higher body weight, a little bit higher stature, and when you kind of use that benchmark of doubling birth body weight by 56 days, the calves are more likely to do this compared to the control. And then again, farm C was kind of similar to farm A. So we combined all the data and you can see that there wasn't really a difference or impact on body weight. There was maybe some slight numerical differences on average daily gain by week 4. But when we looked at all three farms together, calves that were fed kefir were 3 more times likely to double their birth body weight by weaning compared to calves fed the control. So there is some promise there, that they're able to grow a little bit better. The interesting aspect of this was actually the starter intake and not necessarily when they were being supplemented the kefir. So again, we supplemented during the first 21 days and then stopped. But you can see that as we got close to weaning, calves fed kefir previously actually had higher starter dry matter intake than the control calves. So at the time, this kind of puzzled us, but it was also very interesting that we could have this carryover effect from this earlier supplementation period. And so we kind of went to the drawing board again and reconsidered the different production of kefir or kefirian, which is more of that active component of the kefir. Um, Actually, doing this at industrial scales, it's quite difficult to like isolate the kefirian. It's a mixed fermentation. But we saw some other stuff that indicated that if you fermented the kefir with Saccharomyces cerevisiae or brewer's yeast, like if you go out and got instant yeast from the store, you could do this. It actually helped to enhance the kefirian production during fermentation, and there's been some other work in mice, rats, and chicks that has demonstrated some benefits to this. So we thought maybe we could provide some additional intestinal benefit to the developing rumen if we kind of tested this. And so again, this theory was kind of challenging. Can we get more benefit out of that exopolysaccharide, the kefirian, during the fermentation? Um, Maybe we could get some additional metabolic or intestinal development. And so we kind of sought out to try this, right? We wanted to see if it would work as a way to improve the functionality of this kefir. And so we started with some benchtop stuff where we kind of evaluate different concentrations of how much yeast we'd add to the fermentation in terms of the kefir grain. So we had three different setups where we added 1 liter of saleable milk to different concentrations of kefir grain and yeast. And then we extracted the exopolysaccharide to see on a weight basis how much was there. The 1% that we tested was actually the most optimized, so that's kind of what we went for our next field study. And so we did this comparison of normally fermented kefir to the kind of yeast powder addition. We fed it for a little bit longer this time for 28 days to see if we could get some additional benefit to doing this and looked at the effect on the calves. So we evaluated supplementing kefir fermented with or without the Saccharomyces cerevisiae compared to the control. So we had three different treatments that we were feeding this time. And so again, kind of similar to the first study, we were interested to see if we could see any health benefits, but the kind of take homes here is that there was no difference compared to the control between either the calves fed the straight kefir fermentation or the yeast and kefir. So we didn't really see any benefits in terms of health. But again, we did see some differences in terms of starter intake. So again, we supplemented for the first 4 weeks, but then we did see some benefit in terms of starter intake after the fact with the calves that were supplemented with either the yeast and kefir or the kefir having more starter intake than the control calves. Unfortunately, this didn't really translate to body weight. We did track them for a week after weaning, but really didn't go into our terms of body weight changes. So in general, there's been no effect on stature, average daily gain, feed efficiency, or health events were observed, but there does seem to be some positive effects in terms of starter dry matter intake that could impact weaning or maybe future health of the gastrointestinal tract. So the last little bit that I want to kind of walk through in terms of this interaction between different microbial populations and this kind of system here is what other things that might be influencing it and thinking about the environment. What can we do in terms of the housing that our calves are in, or maybe potential pathogen exposure that could be coming from the environment and really disrupting this balance between the microbial populations and the mucosa. So thinking again about positive biofilms, right? There's been examples in swine and poultry that beneficial biofilms can be used to complement cleaning and disinfection procedures. These beneficial biofilms can be applied after cleaning and prior to animal entry, and it's been shown to reduce enteric pathogens on surfaces and bedding and reduce mortality in piglets and broilers. So, with this information, we're really interested in um, evaluating this in the calf program and seeing if there's additional benefits within this susceptible time as well. And to date, before we had done any work with this, it had not been evaluated yet in a calf environment. So one of my previous grad students, she worked on this project where we used a multi-strain biofilming forming cocktail of Bacillus and Pediococcus species, and looked at how it altered the microbial composition on polyethylene calf surfaces. And so we looked at both the adherence and growth of these beneficial bacteria on that hutch surface, right? It's a pretty common housing for our calves. And then also evaluated if the application, how long it lasted or what it did in terms of our normal cleaning procedures. So we had a couple different parts to this. One of it was what we actually applied um, the biofilms to this calf surfaces. So you can see that Carrie was cleaning our hutches according to our normal protocol. We let them dry, added bedding, and then we had the application of our treatments. And then we took samples 24 hours after the positive biofilm was put onto the surfaces, and then we added a calf to the hutch and then continued to measure those surfaces for 7, 14, and 21 days post application. And so for this, we had three treatments. We had one that was the biofilm. So it was this cocktail of Bacillus and Pediococcus species. I'm not sure exactly if it's actually on the market in the United States. It's available in Europe, and that's where the application has been more widely used to date in those poultry and swine facilities. But we were testing it here, and then distilled water as like kind of a moisture application, and then no application on the surface. And so we first tested this on some pieces of the polyethylene hutches within the lab just to confirm that it would actually adhere to the plastic. And so good news, it did. And so over the first 24 to 72 hours, we see that there's growth of these positive biofilms on those hutch surfaces. And then these are from the samples that we took from the hutches where the calves were there. So these are the relative abundance of different genuses of bacteria. You can see that beforehand, after they're clean, there's still a host of different things that are within that hutch, but kind of a mixed bag. But then you can kind of see for sure with the hutches that were had the biofilm applied. You see some of that pediococcus really take effect 24 hours after um, that application. So, kind of indicating that it was growing, it was doing its job of kind of limiting the other bacteria species that were there. And that was maintained somewhat during the 7 days after it was applied. But then we start to see more of that kind of mixed bag of what was there 14 and 21 days after that application. And so one picture for me that really helps to kind of put this in perspective as opposed to those figures is that this is a biofilm treated hutch. So you can see that there's a lot less diversity and coloring of the colonies that are on this plate compared to the control shown here. So you get a lot more kind of yucky colonies or things that you would probably think are bad. And so these plates really kind of do for me, the kind of indication that they're kind of limiting that other colonies really taking over. And so I think this helps to provide further evidence that there's some benefit to these beneficial biofilms in livestock environments. And it definitely decreases the species heterogeneity when we apply this. Some other applications that I've seen recently or have been brought up is the application of an inoculant or something like this in bedding for our cows and mastitis prevention. So that's something that we're seeing more of also, and we have similar kind of application. So just to wrap things up, I hope you can kind of appreciate that not all biofilms are bad, but we can actually use many of them to our benefit. A lot of the work we've done with supplementing kefir has shown a little bit of benefit in terms of starter intake, but overall, maybe not the like magic bullet for health and some of those other things in the early pre-weaning period. But there's obviously a lot of other probiotics, direct-fed microbials that have been researched as well and could be of benefit as yeah, within your program. And that in terms of environmental cleanliness, I think there is a big positive here in terms of I think this will become more widespread and have more application. We definitely need to follow up on the work that we did. But I think any way that we can kind of maintain that environmental cleanliness would be a benefit to our animals. And so if we can use these to our benefit, I think that would be a great tool in our toolbox to kind of move forward. So with that, I'd be happy to answer any questions. And thank you for your attention and interest in our work.
Well, thanks, Dr. Morrison, for that great information. I think I have a better understanding of what you mean by positive biofilms after listening to you today, so I appreciate that. Um, just as we're taking questions here, I would just note we did put the evaluation link into the chat. So before people log off, if they could click on that and just evaluate our program here, helps us to do our educational programming with extension and outreach here. So I see, Fred, you had a question here about the fur grains. Will the grains degrade from one generation to the next and change usefulness?
Yeah,
I th-
sorry. Yes, that's something that we probably need a little bit more information. It is kind of like a little bit wild in terms of what is there. So it could evolve over time in terms of what kind of actors are within that fermentation. And so it can change, and I think it's something that we should look into more in terms of how that might evolve over time. But you do kind of perpetuate like survival of the fittest a little bit of what's there and what could kind of come into your fermentation. So I would assume there's probably some differences in the kefir grains that you could get. Like you can literally order these off of Amazon. So um, there's probably some diversity in what is actually there.
the reason I ask is because we can use the yeast, then we make hard cider about 3 generations, and then
Yeah.
it starts changing the product on us.
Yeah, I would need to know a little bit. I don't know specifically, but I would assume that there are some changes over time. So that would be something that there's probably a limit of how much you could actually use this. But
And I had a question about the biofilm work that you were doing. Does the weather play a part in the efficacy of the beneficial biofilm? Like if you are applying it in winter versus summer?
Yeah, we did stack our cards for that study. We were kind of getting this first pass, and so we did do it in the summer. And that would definitely be a question that I would have as well following up. You definitely would assume that there'd be more positive growth in terms of the summer conditions and their ability to kind of exist on those surfaces. But then, yes, once it comes to winter, especially northern New York or other places that
Mhm.
get quite cold, I would assume that those dynamics could change as well.
Fred, are you seeing any other questions or comments in the chat?
Nope, I think we've got all of those taken.
All right. Well, Dr. Morrison, again, I want to thank you for the information here today. And for those online, we will be back next Wednesday for the next Raising Your Dairy Best Heifer webinar. So hope you can tune in then and give us about a week to edit the webinar, and we'll have it posted on our YouTube channel. So again, thanks for logging on, and we'll see you soon. Thank you.